So good morning, students. So now we have to discuss about numerical differentiation for finding the first and second derivatives. So numerical differentiation is the process of computing the values of dy by dx, d square y by dx squared for some particular values of x from the given data x comma y, where y is not known explicitly. So now we have to identify the derivatives y dash and y double dash are dy by dx, d square y by dx squared for the given data. So we need the data actually. Before that, we have to discuss what are the formulas we have to identify. Learn Newton's formula for the derivatives at x does not equal to x naught using forward differences. Y dash or dy by dx equal to 1 by h delta y naught plus 2 times of u minus 1 by 2 factorial into delta square y naught plus 3 times of u square minus 6u plus 2 divided by 3 factorial delta cube y naught plus and so on. For the second derivative y double dash d square y by dx square equal to 1 by h square delta square y naught plus u minus 1 delta cube y naught plus 6 times of u square minus 18 times of u plus 11 divided by 12 delta power 4 y naught plus and so on. Right? So where u equal to x minus x naught by h. Here I gave you the third derivative formula as well. For this, you may know what is u here and what is delta, what is y naught and so on. To tell you, in the problem, they will give you some data such as x and y. The values of x and y will be given in the questions. X, for example, x 0, 1, 2, 3, 4, and 5, followed by y is given in the question itself, that is y equal to f of x. They gave some function. Instead, they will give you some values of y. When x equal to 0, the value of y is 11. And when x equal to 1, value of y may be 15, 21, 33, 45, 67. So these are the values of x and y. For that, we have to identify the derivative value. We have to identify the derivative at x equal to 0. They're asking to identify the y dash value or y double dash value at x equal to 5. Okay, and here the value of x starts from x naught, x1, x2, and so on up to xn. First value of x is x naught. The first value of y is y naught as well, y1, y2, and so on, yn. So these are the values of x and y, various values of x and y. And here they're asking to identify the y dash value. For that, we need the value of h. What is h? The length of the interval is called as int x or h value. Starts from 0, end with 1, then 2, 3, 4, and 5. So the length of the interval is 1. The length of the interval is 1. And one more thing is the length of the interval should be equal. Then only we can apply Newton's forward and backward interpolation formula. Right? So if not, the method fails. We have to use Newton's divider difference formula. So that the value of x equally spaced. The value of x should be equally spaced. Otherwise, we can't use this formula. Okay, and here what is h? H is the length of the interval, and y naught is the first value of y. What is delta y naught? I'll tell you uh, later. And what is u? U is x minus x naught. Suppose they're asking to identify the value of y dash at x equal to uh, 5. The value of x will be 5 minus x naught. The first value of x is x naught, 0. Right? What is the value of h? H is 1. So you can substitute h equal to 1, x equal to 5, x naught equal to 0. Then we'll get it. U value will be 5. Right? Then you can substitute the value of u in that particular formula. The thing is to find the value of delta y naught, delta square y naught, delta cube y naught, and so on. Okay, so it's based on the formula, it may extend it, right? Okay, so this is terms we have to discuss before uh, starting the problems. Okay, so nothing is there in all the other cases. We are finding delta square, delta cube, delta power 4, and so on. Here, delta is a forward difference operator. Delta is a forward difference operator. And del is the backward difference operator we are going to discuss now. Right. Newton's formula for the derivative at x equal to x naught using the forward differences. When the value of x equal to x naught, the formula will be y dash equal to dy by dx equal 1 by h delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught, so on. Similarly, we have second derivative and third derivative for your reference. The thing is, first you have to choose the proper formula for the particular problem. So based on the value of the x, you have to use forward or backward interpolation formula, right? So I have to tell you when we have to use the forward and backward difference, and when we have to use first formula and the second one. This is the formula number 1 and the formula number 2. Oh, here I have mentioned the value of x and y previously. 0, 1, 2, 3, 4, 5, and so on. It is 11 and 15, 21, 17, something like that, right? And here, suppose they are asking to find out the value of y dash at x equal to 0, you can choose the first formula, sorry, second formula, right? When x equal to x naught, which means the x value and x naught value are similar. X value and x naught value are similar, so you can use second formula. Suppose they're asking to identify at x equal to 1, right? So we have to use first formula. Okay, so you have to divide the table equally into two parts. If the value of x is in the first part of the table value, you can use forward difference. If it is the value of x is the second part of the table value, we can use backward difference. This is a usual method to choose the formula properly. Okay, so when the value of x is exactly x naught, can use second formula and this one. When x is not equal to x naught but nearer to the x naught, then you can use first formula. Okay, so this is the important thing for the given formula. So if you are choosing the wrong formula, you will get the wrong answer. Okay, you got choose the proper formula for the proper question. Okay, so I have two forward difference formula. One is x equal to x naught when x is does not equal to x naught. Okay, when at x does not equal x naught, at x equal x naught, we have two different types of formula based on your data for the question. Similarly, we have the backward difference formula. We have a backward difference formula, x equal to and y equal to. And suppose I have seven x values such as 2, 4, 6, 8, 10, 12, and 14. So it is equally spaced. The length of the interval is 2. So we may use Newton's forward and backward interpolation formula for this problem. And I have some values like 11, 121, 160, 171, 181, 189, something like that, right? Suppose they're asking to identify, find y dash at x equal to 14. 189 is the value of y at x equal to 14. The question is to find y dash at x equal to 14. Okay, so see the difference. They're asking to identify the derivative value at x equal to 14. So x value is 14 and this is xn, right? I told you already x naught starts with x naught, x1, x2, and so on up to xn, right? When x equal to xn, you can use this tree formula for finding first derivative, second derivative, third derivative respectively. Suppose they're asking to identify at x equal to 11 or 10 and 10 is nearer to xn. So can proceed backward difference at x does not equal to xn. Okay, so you have to memorize all these formula. So okay, so you should memorize the formula, then you can proceed the solve the problem. The thing is to memorize the formula properly. Okay, so we have used two different operators, delta, del. Delta is for forward difference, del is for backward difference. So better to use two formulas at x equal to x naught, at x equal to xn. So no need of x does not equal to x naught, x does not equal to xn. I'll tell you the shortcut method to find the answer by using only two formulas. So we can use at x equal to x naught, at x equal to xn. The formula is also very simple. Okay, so you can easily refer it. For forward difference, you can use delta. For backward difference, you can use del. For forward, you can use the y naught and backward difference yn. For forward, you can use the variable u and backward, you have to use the variable v. So these are the three important things in this formula. Okay, so x equal to x naught forward difference, x equal to xn is a backward difference. When we have to use backward or forward, you have a list of values, right? X and y. 1, 2, 3, 4, 5, 7, 11, 18, 18, 25, 37. Okay, suppose they're asking to identify at x equal to x naught. We can divide it into two parts of this table value. Okay, when x equal to x naught or x equal to 1.5 or x equal to 2 or x equal to 1, it comes under forward difference. Okay, so when x, the value of x in the first part of this, and this is the part 1 and this is part 2 of the table. When x appears in the first part of the table value, we can use forward. When x appears in the second part of the table value, we can use backward difference form. That's the thing which we have discussed earlier. Okay, so this is a way to classify the formula. Okay, now we can go to the problems. Problem number 1. Look at the question number 1. Find the first two derivatives of x power 1 by 3 at x equal to 50 and x equal to 56 for the following table. Okay, so I have no, and here they're asking to identify two different values, right? They're asking to find out uh, first two derivatives y dash and y double dash at two different values of x at x equal to 50 at x equal to 56. So there are two different values of x. One is represent the first value of x, another one represent the last value of x or xn. And this is called x naught and this is xn. Very first value of x is x naught, very last value of x is xn. So we can proceed to formulas for finding first two derivatives y dash and y double dash. Okay, so for x equal to x naught appears in the first part of the table value. You can divide it into two part of the table, and x50 appears in the first part of the table value and 56 appears in the second part of the table value. So we can proceed forward difference when x equal to 50, right? And then you can proceed backward difference when x equal to 56, right? So now let's see. Newton's forward and backward difference formula with the difference table. For that, we have to find the difference table. So first, we have to write construct the table. The first column represents the values of x. The value of x and y is given in the question itself. Okay, so the value of x is given 50, 51, 52, 53, 54, 55, and 56, which are given in the question itself. Then the value of followed by the value of y is given, right? So we have to find the forward and backward differences. Very simple. We just subtract it. 3.7084 minus 3.6840 gives you 0.0244. Similarly, you can subtract these two. 3.7325 minus 3.7084, we have 0.0241. Okay, again, right, this here. 3.7563 minus 3.7325 is equal to 0.0238. Next, 3.7798 minus 3.7563. Next one, 3.8259 minus 3.7798. Last one, 3.8259 minus 3.8259 equal to, there is a mistake in it. It's not exactly this one. It becomes 0, so that there is some differences in the last two values. As you can see here, 3.8030 here, 3.8259. So, which are not equal, both, right? So here, 3.8030. So that we get the 0.0229. Again, you have to subtract these two. Continue this process until we have the 0 or any finite value in the single value. So hereafter, no need to proceed to the next values, because 0 minus 0 again 0, 0 minus 0, 0, 0 minus 0, 0. So we have stopped to the third difference. No need to proceed fourth difference because all the values are zeros. We don't have any non-zero values to calculate it. So we can stop the calculating it up to third derivative, third difference. Now go for the forward difference formula. In forward difference, we have seen the value of delta y, delta square y, delta cube y, everything, right? So here we have to choose very first value of each column except first two columns, right? We have to substitute these three values in the formula. We can get first derivative at x equal to 50. Similarly, we can find second derivative at x equal to 50. And here you can use backward difference formula at x equal to 56. So the red color values indicates the forward and backward difference values. Okay, so rest of the thing no need to substitute in the formula, right? So we need the very first values of the differences: first difference, second difference, third differences. Very last value of differences: first, second, third. You better to use when you use backward difference. You can use instead delta. For forward, we can use delta. Backward, use del. Newton's formula for the derivatives at x equal to x naught using forward differences, which means we have to identify the value of y dash at x equal to 50. The value of h is 1 actually, because we have started with 50 and then it gradually increasing with the help of h. 50, 51, 52, 53, 54, 55, and 56. So the value of h is 1. H is nothing but in text, or we can call it as length of the interval. Okay, so we have taken the very first value of the first difference, here second difference, third difference. And after substituting it, we get 0.02455. This is the first derivative value of the function at x equal to 50. Similarly, we can find the second derivative value of the function at x equal to 50 is minus 0.0003. Similarly, we can find Newton's formula for the derivatives at x equal to xn using backward differences. And here for forward, I told you to use delta. For backward, we have to use del. For forward, we are using y naught, and here we will be using yn. Okay, so these are the two differences. And here look at this. In formula, we have positive, negative alternatively. For backward difference, you can assign positive for all the terms. Okay, so this is a way to calculate the derivatives. Newton's forward, Newton's backward difference formula. As you can see on the screen, told you instead of delta we have used del for backward difference. For y naught we have yn. All the terms are positive, right? Positive here, positive. All the coefficients are similar, just like forward difference terms. There is no differences between the coefficients of forward and backward differences. Okay, so now we can go for when h equal to 1, we get the first derivative value 0.02275. Second derivative 1 by 1 square minus 0.0003 plus 0 plus 0 plus 0 equal to minus 0.0003. Okay, so these are the derivative values for the given problem. So we have started with a very basic one, a very simple problem we have chosen to find a first and second derivative value of the function at x equal to 50 and x equal to 56. So the process is very easy and very simple as well. And the thing is to memorize the formula properly. Okay, now we can move on to problem number 2. Find the value of secant 31 degree from the following data. The data represents the angle theta and tan theta values is given in the question. They're asking to find the secant theta, that is secant 31 actually. So indirectly they're asking to find out the first derivative. So differentiation of tan theta, it becomes secant square theta, right? So by taking square root of the secant square will give you secant theta, right? So indirectly they are asking to find the first derivative for the given data at x equal to 31. Here not x, theta. Uh, will you use forward or backward? Which one we have to choose for this problem? So 31 is the beginning of the stable value. So we should use forward difference always when x is the first value of x or the beginning of the table value. Okay, go for the difference table. First you have to write the first two columns, you have to fill it. First two columns is given in the question, values are given in the question. Theta 31, 32, 33, 34. 31, 32, 33, 34. Then tan theta value, tan theta is, and this is y actually 0.6249, 0.6494, 0.6745. Go for the forward difference. 0.6249 minus 0.6008, we get 0.0241. Again, subtracted 0.6494 minus 0.6249, we get 0.0245. 0.6447 minus 0.6494, we get 0.0251. Then 0.0245 minus 0.0241, we get 0.0004. Again, we can subtract 0.0251 minus 0.0245 equal to 0.0006. Then again subtract 0.0006 minus 0.0004, we get 0.0002. The process, we may not proceed further because we have a single value, so we may not subtract with any other values. So we can stop the process. Now we found the difference table. Now you have to use the forward difference derivative. We have to find the derivative y dash. Here y dash is d by d theta. Okay, so now you have to choose the very first value. So the differences, first difference, second and third difference. Substitute these three values in the formula. As you can see, uh, the formula is 1 by h of delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught and so on. And this is delta y naught value, delta square y naught, delta cube y naught. By substituting all these things, and finally we have to calculate it, we get 57.2956. And here you should know what is here theta. So 1 theta is equivalent to pi by 180, right? 1 theta is equal to pi by 180. So by the value of pi is 3.1416 divided by 180. So uh, here 1 theta is 57.2956 into 0.02396. And finally we obtain the first derivative, y dash equal to 1.3732. But the question is not completed yet, because the question is to find the secant theta, secant 31 degree. What we found out here, we found y dash value. Y dash is, what is y? Y is tan theta. What is y dash? Secant square theta. We found the secant square. So d by d theta of tan theta tan 31 degree equal to secant square 31. So we have the value 1.3732, but we need secant 31. So you have to take square root of 1.3732 will gives you the required answer, 1.1718. This is the required answer for this problem. So note it down. If you have any doubts, you can uh, ask me the questions. Okay, so I hope you understood everything what we have discussed earlier. Now let's proceed the next problem. Question number 3. The table given below reveals the velocity v of a body during the time t. Find its acceleration at 1.1 at t equal to 1.1. So here, look at this 1.1 is not a first value of x, which is the second value of x. So we proceed forward difference. Okay, so we have to proceed the forward difference. I gave you the formula in the beginning of this class. Velocity is v and acceleration is dv by dt. They're asking to find out the accelerations. That means we have to find the first derivative. The differentiation of velocity is acceleration. Okay, now as usual, you can find the difference table. In the first column, you write the value of t. In the second column, you write the value of v, velocity. Then you can start find the differences, and this is the difference table. Okay. 47.7 minus 43.1 gives you 4.6. 52.1 minus 47.7 gives you 4.4. 56.4 minus 52.1 becomes 4.3. 60.8 minus 56.4, we get 4.4. Again, 4.4 minus 4.6 gives you minus 0.2. 4.3 minus 4.4 is minus 0.1. 4.4 minus 4.3 is minus 0.1 again. Now, minus 0.1, minus of minus plus 0.2 gives you plus 0.1. Minus 0.1, right? Minus 0.1, minus of minus plus here, so it becomes not 0.2 to 0. Here we have a 0, and here minus here. Look at this, it's not listen, it's correct one actually. Here the mistake is in here, and this is not a minus, plus, this is not a minus, here plus, so 0.1 minus of minus plus 0.1, it becomes 0.2. So 0.1 minus 0.1, we have a 0.1, right? So here we have a mistake here. This is not a minus, plus. Okay, so we found the difference table here. Now we can use the proper formula, and we can solve this problem in two ways. One is use at x does not equal to x naught formula. I have given some formulas. At x does not equal to x naught. For this problem, you can use at x does not equal to x naught, or you can use at x equal to x naught. When you use at x equal to x naught, you can take the very second value of the column. If you use the first column, you can proceed, you take the very first value of y. the red color values. Okay, so choice is yours. You can use any one of the formula. At x does not equal x naught, at x equal to x naught. I gave you four mm, four different formulas. Can show you. Uh, at x does not equal to x naught, at x equal to x naught, at x does not equal to x n, at x equal to x naught. So we have four different formulas, right? So based on the value of x, we can choose first one, second one, third one, and fourth one. Okay. So now we are discussing the problems for the first one. Okay. So this is the formula for the first one. We know the forward difference delta y naught, delta square y naught, delta cube y naught, delta power 4 y naught. And we know how to calculate the value of u as well. U equal to x minus x naught by h. X is 1.1, h is 1, x naught is 1. So the value of u is 0.1. You can substitute u value and forward difference operator values. Finally, we obtain y dash 44.917 is the acceleration of the given problem. So this is one of the way to calculate the acceleration for this problem. The second way I have to tell you, because why I'm saying is so most of the students feel that to memorize the formula. Very difficult to memorize this formula. So they are asking to, so they may prefer to use the formula such as 1 by h of 1 delta y naught minus 1 by 2 delta square y naught plus 1 by 3 delta cube y naught and so on. I think the second formula they're asking to use it. So you can proceed the second simple formula for this problem also, but the choosing value is different. You have to choose the different value of x. I have to tell you what is the particular value. So a liter is another way to solve this problem. Look at this, the same table value. In the previous case, we have chosen the very first value of the forward difference operators. Delta V, delta square V, delta Q, V and so on. Okay, so instead you can look at the second term, second values of each column, because they are asking to find the derivative at x equal to 1.4, sorry 1.1. So 1.1 is situated in the second value of the column. So that you have to choose the second value of the forward differences in each column. Okay, suppose we have 1.2, so which is situated in the third element of the first column. So you have to choose the third element of each column. Okay, so for substituting the forward and backward difference formulas. So that's your choice. You can either use first formula. If you use the first formula, you can choose the very first value of forward differences. If you use the usual forward difference formula, we can take the value of forward differences at x equal to some specific point. Suppose 1.1 is, you can choose second one. If 1.2, can choose the third one, third element of each column. Okay, so Uh, that's your choice. Both will gives you nearer answer. Okay, so we may not get exact solution because uh, I told you already we are finding only approximate value, not exact solution we are finding. We are not finding the exact solution. We are finding approximate solution. Okay, so no problems. We can use either forward first formula or second formula for this problem. So we get almost a nearer value 45.1666. In the previous case, we get 44.917, and here we get 45.1666. Okay, so both are not exact solution actually. Okay, so both are we are finding the approximate values, right? So this is a way to find the first and second derivative values. So do it as a homework. Uh, Try to solve this problem yourself. For the given data, x starts from 1 and end with 1.6. They're asking to identify first and second derivative at x equals to 1.1. For this problem, you have to use forward difference. Okay, so either you can use the first formula or second formula, which we have discussed earlier, right? So that's your choice. You can try to solve this problem. I have to show you the solution for this problem as well. Please verify your results. This is going to be your we have chosen the second formula. That will be very easy to calculate it uh, without making any mistakes, because very simple formula we have used 1 by h into delta y naught minus 1 by h square, sorry, 1 by 2 into delta square y naught plus 1 by 3 into delta cube y naught and so on. So 1.1 situated in the second one. So we have to choose the five values in the formula. We'll get the result. Okay. So there's a first derivative value. This is going to be the second derivative value. So try to solve yourself and verify the answer as well. Thank you, students.